Hello.
Yes, sir.
Now is it audible?
Yes, sir. Yes, sir.
Oh, nice. So, okay. So one more is waiting for joining. Okay, let me. Actually, this I'm new to this software, as you people are, I think. So today there is a little bit uh, technical difficulties, but next time onwards it will be all right. So let me see who is there. I think one of your friend has come. I have to permit him. Or is it already okay? Permitted, right? So, Pritika, are you able to hear me? Okay, Nikhil had responded, but I couldn't hear him. What about Pritika? Pritika, are you
Yes,
able to
sir.
hear me?
Yes,
Okay,
sir.
good. And yeah, Priyadarshini, you could hear, right?
Yes, sir.
Okay, good. So I'll just give you a brief introduction about myself. So myself, Ramchandra Dhal. Okay, I am actually PhD in physics, and I have obtained my master degree also in physics, graduation also physics. So all the way, I'm a physics expert, and I have been teaching these courses like for NEET and JEE Mains, and also CBSE board students, as well as other boards also, like IGCSE and West Bengal board. I belong to West Bengal. You might be knowing Kolkata, right? So I am from uh, a place very nearby Kolkata. So all of you are from uh, Chennai or Tamil Nadu, right? What
Yes, sir.
about Priyadarshini? Okay. Anyway, today I'll just give you a brief introduction about the first chapter of 12th syllabus, class 12th, right? All of you are class 12th, I hope. Is that correct? All of you are
Yes, sir.
preparing for board exam. Yeah, board exam. So today we have picked up the book NCERT textbook, and the first chapter will start with. So I'll just share my screen. So are you guys able to see the screen?
Yes, sir.
Okay, the textbook you are able to see, right? The same textbook you people also have. So today we'll start with the first chapter called electric charges and fields. So, and this is actually, we'll be talking about static charges. Mainly we'll be talking about static charges. Okay. So this is the title. This is chapter 1, the electric charges and the fields. And what kind of these charges are, like whether the charges are mobile or static. These charges are static charges. So basically, this is coming under the branch of physics called electrostatics. Electrostatics. Okay. So before we start with the real topic, we should know why do we learn this topic. First of all, you might have seen many phenomena. I'll give some example of this, like all those, like see in the dry weather or maybe in the winter season, we wear sweater and many other woolen clothes, right? But when we take off, what we see, sometimes we hear some crackle sound, right? When we take that off, and we see sometimes uh, there are like many garments like polyester sarees and all. When the ladies are like which ladies are wearing, when they like handle it, they can hear some crackle sound kind of those. Like, and there are many other phenomena where we see uh, the effect of the discharge of static electric charges. Discharge of electric static charges. So one more example I could give you, the light, like when there is thunderstorm, the lightning you see, that lightning also is due to this discharge of electric charges, static electric charges. What do you mean by static? Charges are not moving. Okay. And sometime if you take some piece of paper and just take nearby your TV screen, you could see sometime that those papers will be attracted to the screen and they will stay on the screen for some time. So that is like all these effects which I have told you, these are natural phenomena due to static electric charges. We learn what are the what so today what we learn is we learn what is electric charges. Are you people able to see the screen properly?
Yes, sir.
Okay. Or shall I zoom a bit?
It's clear, sir.
I have zoomed the screen a bit. It is clear. Okay, nice. Okay, so yeah, and one more simple example I can give this effect of static electric charge. If you take a plastic comb and in the dry weather, suppose you have applied a shampoo in your hair, so your hairs also will be nicely dried, and then you just comb your hair and take piece of papers, small piece of paper, and bring the comb after combing your hair near the piece of paper. So what you'll see, they will be attracted to the comb. So these are all effects of static electric charges. Okay, these are very common phenomena, very simple phenomena, but we don't try to find explanation for that. But today we'll try to learn how these things happen. Like, see, we'll in this chapter we'll learn what is electric charges first of all. What is electric charges? So to know that, we'll just go through few things, like few observations, and the electric charges were discovered by many scientists. Like this kind of phenomena they have seen in the nature, and they tried to explain the phenomena for many years, and they could explain successfully. And look, when there is a natural phenomena, we have to come up with some concept to describe that natural phenomena. So see what people have observed, when you take a silk, okay, and rub with glass rod, and suppose the glass rod which is rubbed with silk, you just hang that glass rod with the silk thread. Why do I take silk and glass? First of all, why do we take silk and glass? Actually, silk and glass, these are actually, see, I don't know whether you have learned already in your previous uh, classes, like conductor, conductor, insulator. Have you learned? And semiconductor, kind of those at least term have you heard of?
Yes, sir.
Okay, so I'll just brief out a little bit what is conductor, which has free electrons, right? They have free electrons. Okay, and insulators, they don't have, so don't have, do not have, right? Do not have free electrons. And semiconductor, actually in between conductor and semiconductor, right? They have both bound and free charges, but conductivity wise not that great. Okay, so this is so silk. So which category silk come in? Silk come in insulator category, right? Even glass also come in insulator. So don't have this, don't have actually, do not have free charges. Charges to conduct. So now when you take a silk thread and hang a glass rod, then there is no actually conduction between the silk thread and the glass rod, because these both are insulator. Both silk and glass are insulator. Silk and glass are insulator. So what we do, first we take this silk and then rub it, okay, and that has been hanged with the silk thread, okay, and another glass rod has been rubbed with the silk and brought near to this glass rod which was hanged. So what we see? We see that these two glass rods, they repel each other. Now if you take a and silk cloth and you take a plastic rod, rub with that silk cloth and hang it with silk thread, okay, silk thread. Now take another plastic rod, do the same thing and bring nearby this hanged plastic rod, okay. You'll see then also they are repelling each other. But when you bring glass rod after rubbing with silk, you bring the glass rod and plastic rod nearby, they will be attracting each other. So these phenomena was observed by scientists, and one more phenomena they have observed, that when they see the rod they are bringing with, when they are, suppose this is a glass rod, okay, glass rod. So glass rod, so when they are just touching with the pith ball, they are repelling each other, okay, they are repelling each other. Now look, if we just take silk thread, okay, silk thread, silk thread, they also repel each other. See, suppose I just take a silk thread, a silk cloth, okay, silk cloth, and rub with a glass rod, rub with glass rod. So what happens here actually? See, what happens is actually, see, these people are actually, these both silk and glass rods are insulators, so they don't have charges, free charges. So basically, free charges, we will be learning that there are two kind of charges. One is positive charge, another one is negative charges. And positive charges, long after the discovery of positive and negative aspects, J.J. Thomson has discovered this electron, right? And the opposite charge but same magnitude, that has been uh, actually taken as like just antiparticle of this. So this is positron, it says. But anyway, so there are two entities, positive charge and negative charges. So that is what people have concluded long after. How? Suppose there is a, so what happens when we rub? How do we get? Okay, just before that, I just would like to tell one thing. So when I take any glass rod or any material in that case, so these materials are actually composed of atoms, small atoms, right? Composed of small atoms. So when all the atoms are compact, they are situated very compact manner, then it is actually becoming a solid when they're too much compact each other. So these atoms you can see in a solid, there will be, if I take a standard gram of solid, so of the order of at least 10 to the power 23, Avogadro number of atoms will be there at least. Okay. Now, these many atoms are there, and like these atoms are, or these materials, glass rod, simple glass rod, if you take simple glass rod, so that is actually neutral. Neutral in the sense you don't get shock, there is no charge, no excess charge. So neutral in the neutral means what? Neutral means no excess charge. No excess charges. So, so in this case, what happens? So whatever atoms we have inside this in a compact manner, so all these atoms are actually neutral. So you might have learned already little bit in your previous standard. So we have atoms, right? We have atoms, and we will be learning in this course also that according to Bohr model, so there will be nucleus inside at the center, and electrons will be orbiting around. Electrons will be orbiting around this nucleus. Okay, negative charges. Electrons are negative, and this proton. This is proton. So inside the nucleus, there will be nucleus composed of proton plus neutron. Neutrons. Okay. So, and the number of protons you have in the nucleus. So protons are actually positive charge particle, and neutrons actually neutral particle. So they don't have any charge. Then how come an atom will be neutral? So an atom will be neutral only when the positive charge at the nucleus and the magnitude of the electronic charge in the outer orbit will be same. That means the number, if the number of electrons, that means negative charge. There are number of electrons, suppose 10 number of electrons are there. So you have to have 10 number of positive charge or protons in the nucleus. Then this atom will be neutral. Okay. So and but if suppose I have a glass rod and and silk cloth, so they are neutral means what? There is same number of proton positive charge and same number of negative charges. Okay, in this hole. And if I have cloth, cloth also will be neutral. Silk cloth. This is glass rod. Suppose there also there may be some 20 positive charges and minus 20 negative charges. Okay, that's how they will be neutral. But when I rub with this glass rod, what happens? See, they have both have electrons and the outer orbit electrons, what they will try to do. So the electron, suppose from the glass rod, will go into the silk cloth. Okay, and suppose 4 electrons has gone into the silk cloth. That means what? There are 4 atoms which has losen 4 such electron. That means what will be happening in the nucleus? 4 amount of positive charge will be accessed, right? 4 amount of positive charge will be accessed in the nucleus. So that's how the number. So when we rub the glass rod with this kind of cloth, or suppose in case of your comb and hair, there also the comb might be losing electrons and hair might be taking up the electrons. So if somebody is taking electrons, suppose I had neutral, suppose one positive and one negative. So this is a neutral one. Okay. So but this atom, if I give one electron to this, then what will happen? I am not giving a positive charge. I'm just giving one electron. That means negative charge. So what will happen here? One negative charge will be excess because it is not being able to nullify. Earlier, in case of neutral atom, positive charge and negative charge, they are nullifying each other. The amount of, see, suppose there are 10 negative positive charge and there are 10 negative charge, so they will nullify. So what will be the effective charge? 0. They will nullify each other. There is no excess charge. But when I add one electron, but positive charge is same, some 10. So here 10 positive charges are there, but now 11 negative charges are there. So there will be one excess electron. So this is how when we rub the silk cloth with the rod will be losing its electron and transferring it to the cloth, this silk cloth. Okay, that means what? If there are 4 electrons, it is losing or transferring to the cloth, then there will be 4 atoms which will be gaining 4 excess charges, positive charges. So if it is, see, if the cloth is getting 4 negative charges, 4 electrons, then this glass rod with which I have rubbed with will get 4 such positive charges. Okay. So this is how when there is an excess of charge, then it will not be neutral. It will be then electrified. This is called electrified. Electrified. It will be called as electrified. Okay, electrified. And earlier it was neutral. Electrified means there is excess charge. Now look in the previous figure, what we have shown, there are 2 glass rods. Suppose glass rod is losing electron upon rubbing. If I have 2 glass rods, if I rub with the same material, silk, then both the glass rods will be positively charged. And when we bring one near to other, so they will be repelling each other. That means, so this is also one fact we can see that with the same, we have taken 2 glass rods we have rubbed with the same material, that is the silk cloth, and for that case these glass rods are repelling each other. That means what? These glass rods are getting one kind of charge, obviously same kind of charges, because we have rubbed with the same material, silk. So they are having same kind of charges, and then the same kind of charges are repelling each other. So what we can see from here, this observation, the same kind of charge repels each other. same kind of charges repel each other. Okay. And see the last example, last figure. See, you look here, the same silk cloth I have taken, but I have taken now two different rod. One is glass rod, another one is plastic rod. So the materials are different. One is glass, another one is plastic and glass. Now I have wrapped with the same material, but see, even though they have been wrapped with the same material, but they don't have the same tendency. Plastic may have tendency to accept electrons. So the plastic has accepted electron from the silk. So in that case, silk will be positively charged and this plastic will be negatively charged, which has been shown here, even in you can see in your book also later. So plastic has loosened its, like it has accepted electrons, whereas the silk has uh, loosened or transferred the electron to the plastic rod. And in the same way, the glass rod has been wrapped with the silk. So in that case, silk become negative and glass rod become positive. Now, if you bring these two charges, these two rods nearby, then it is seen that they are attracting. So what we have done here, we have taken a single material, silk, with which we are rubbing two different material, glass and plastic. So obviously the different materials will be having different tendency. So we can guess that these two will be having differently electrified. One will be electrified with positive charge, another one will be electrified with negative charge. That means one will have plastic rod will have excess of some charge and the other one will be having excess of some other charge. So so in this case we can see, since these two are attracting each other, we can say from this experiment we can say that this is third experiment. So from this third observation we can say that unlike charge, same charge means like charge, I can say like charge, same kind of charge means like charges, and this is unlike charges. Unlike charges attracts each other. Okay, attracts each other. So from here we can understand that there are two different types of charges. So and it was American scientist Franklin Benjamin who could guess that these two charges, two kind of charges may be positive and negative, and later on they have been named as like negative has been named as electron and positive maybe proton or positron. Okay, proton actually. Okay, charges are same. Okay, magnitude of the charges are same but sign is different. So this is how we can understand from this experiment that or observations that there are two kind of charges. One is positive charge, another one is negative charge. So this much we have learned from this experiment. Now what we'll do, so if you guys should read it carefully, and you can, so if you have any doubt further you can ask me later. So so you could understand, right, how do we get uh, like our small pieces of paper gets attracted by your comb after combing your hair. So after combing your hair, so you can just give me simple explanation now that comb has obtained or has got some excess charge, and at the same time these paper pieces are also having, when I am bringing or touching the comb, we are just say if I just touch the comb, what happens? Suppose this is a piece of paper. So when I bring a comb nearby, so what it does, suppose it has certain amount of charges, suppose negative charges maybe. Okay, so when it is brought here, actually these also will get induced with some charges, opposite charges. Okay, they will get induced with opposite charges. So that's how they get attracted to the comb. Okay, like this, they gets attracted. Okay, so we'll see again how we can charge with induction and charge with rubbing and all those things we'll see in the next section maybe. So this, yeah, so this first part maybe little bit of like what to say, little bit of not that interesting, like not that much interesting, but it is interesting to know the experiments with which we have come to know about the charges. So now what we'll learn another good uh, thing, that there is a simple apparatus that is called gold lip electroscope. If you see in your book, it is, yeah, so it is gold lip electroscope. It is called gold leaf electroscope. This is the one, gold leaf electroscope. So you can see that there is a closed box. Okay, closed box, and which has glass windows. That means you can see through it. And sometimes like this is enclosed with a rubber lid. Actually, you have a closed box which has glass windows. Okay, and you have a small window, like small hole over here, through which you can pass a metallic rod. This is a metal rod. Okay, and this is a rubber lid to this hole. And sometimes this enclosure or the box has to be evacuated. That means no air, okay, should be there inside that. Okay, no air should be there inside, so that we can see the experiment properly. We can, yeah, see the effect of the charges properly inside that. So actually this is called gold leaf uh, electroscope. What it does actually, uh, we can see the presence of charge. If we bring one body near this knob, this metal knob, we can get an idea whether the metal knob is charged or not. And sometimes there are some other arrangement through which we can know the nature of the charge also, whether it is positively charged or negatively charged. So this is a simple electroscope, gold leaf electroscope, where you have a box, you have a metal rod and metal knob top of that. Metal means what? It can conduct the charges. Okay, can pass the charges from one point to another point. So what do you mean by conductor? Conductor can have mobile electrons. That means the electrons inside or the charges inside the conductor can move from one point to another point. So that's why we have taken metal knob and metal rod, so that if we touch with some charged body, that charge will go to directly to the bottom of that rod, and at the bottom of the rod we have taken same size and same shape two gold uh, thin sheets. Those are called gold leaf, as you can see from here. So this is gold leaf. There are two gold sheets, thin sheets, very thin sheets. They are attached to the end of the knob. This this rod, metal rod. And now if this is evacuated, so any other, so the evacuated means this is isolated system now. So there is no other effect, okay, due to air or any other molecules or something like that. So now if you bring bring one charged body, suppose a glass rod which is positively charged, if you bring near the knob and touch it, what will happen? So this is a positively charged rod, and this is a knob, metal knob, which is neutral. Okay, neutral in the beginning. It is neutral, but what will happen when you bring a charged rod and touch with this? So the positive charges will be repelled. Positive charges will be repelled. Okay, or in other words, I can say negative charges will be attracted towards the glass rod, and all the positive charges, suppose uh, goes into the rod, glass rod, it is attracted, and at the same time when the positive charges are attracted by the rod, sorry, negative charges or the electrons are attracted by the rod, the positive charges will be repelled. Okay, or maybe I can say all the like the rod will be positively charged finally. If you are not able to understand, I'll just try to explain over here. Okay, suppose I have positively charged rod, a glass rod. Okay, now I have the knob of the electroscope, and this is the rod. These are all metal actually. This is a metal rod. And see, initially they are neutral. That means positive charges and negative charges are equal in number. Now what happens when it is charged with this positive rod? So positive charge, see, negative charges will be attracted towards this rod, towards this rod, and then the rod will be effectively actually having, see, the rod will be effectively positive charges, and that positive charges will be uh, given to these foils also. Okay, glass, that is the gold foils. Okay, or the gold lips, you can see that the positive charges will be shared or distributed over the glass, sorry, gold leaf. Okay, gold lips. So when, and see, these are actually attached to both are actually having positive charge. Now both the leaves have positive charge, and since they have positive charge, so what they will do, they will repel each other, and you can see the deflection. This is called gold leaf deflection, or this is called divergence. Okay, gold leaf will be diverged from each other. What will happen? There are, see, there are two leaves like this, two plates like this. Okay, two plates like this. So they were first, you can see that they were very nearby fast, but when they are positively charged, both are actually with positive charge, they will be repelling each other, and so repelling each other means they will be going or diverging from one another. Okay, they will be diverging from one another. Okay, now they will be diverging, the distance between them will be more. Okay, so what I was trying to say, that is, was my voice breaking all the way since beginning, and now you are saying, is that like that?
No, sir. When I heard extra noise, I said you, sir.
Okay, fine. So look here. Uh, so conductors are having free electrons. What are free electrons? Free or mobile electrons? These are called mobile electrons. Mobile electrons. So when you just set off an electric field, okay, or maybe when, see, you have a conductor, inside the conductor, you know what will happen? Electrons, there are free electrons. Okay, first of all, let me tell you what is free electron. Even though this will be learning in the later portion of this, like second part of this 12 uh, course physics, Still I'll tell you about the Bohr model. Like there is, so according to Bohr model, uh, there will be nucleus at the center which will be having the positive charge and all the masses of the atom, and in and out in outside what will happen. So there will be, actually these are circular, this should be circular orbits. So around the nucleus there will be certain circular orbits, uh, in which the electrons are orbiting the nucleus just like our planetary motion. Okay, like all the planets, you can take up Earth. There is a sun, right? This is sun, and then Earth is moving around it. Similar to that, the Bohr has given a model that the positive charge is situated at the nucleus and the negative charges are orbiting around it in different orbits. Now look, these electrons are actually attracted by this. See, we'll learn again that what is Coulomb force. So there is a force between this electron and this positive charge, and it is actually attracting all of them. So that is how the electrons are in a certain atom. They are actually orbiting around the nucleus and they are staying along with a certain atom because of this attractive force. Now when you go outer and outer and outer orbit, like see this is first orbit, this second orbit, then third orbit. If I go for some other orbit like fourth, fifth orbit and all, so these are called outer orbit. So electrons in those orbits are called outer or outer electrons. Outer electrons, or these are called valence electron. Valence electron. What are these called? Valence electron. You might have learned in your chemistry. Valence electrons. So these valence electrons are loosely bound to the nucleus. They are loosely bound to the nucleus. So that means what? If I give a simple some amount of force, this electron can go away from this atom itself. So these are called free electrons. Okay, when the valence electrons are loosely bound electron. So when I have a conductor like this, there are many atoms like that. Okay, so many atoms, and they have their outer orbit electrons or valence electrons which are loosely bound to the nucleus, and they will be free to move around anywhere, inside this. So that is why these are called actually free electrons, and that is why conductor can conduct electricity. Conducting electricity means what? You have some kind of charges which are moving in a particular direction. Suppose if I say these are electrons, so electrons are moving in a particular direction. Okay, so this is called electricity. So flow of charges. Conductor can allows the flow of charges through it. Okay, allows the flow of charges. Okay, so this is brief about conductor. Conductor has mobile electrons and it can conduct or allow electricity to pass through it, or allows the flow of charges. Where there is flow of charge, there will be electricity or current. Now we'll see what is insulator. Okay, I'll take some 5 minutes more, then I'll maybe conclude. So I'll just conclude with this insulator part. So insulator means what? See, as I said, there is an atom inside. See, at the center there is nucleus, positive charge, electrons are orbiting. So in this case, like this force is so strong that no electron will be loosely bound. These are strongly bound electron. Strongly bound to the nucleus. Strongly bound to the nucleus. These electrons are strongly bound to the nucleus. Okay. So then what happens when I take an insulator material? I have many atoms. Similarly, I have many atoms. But see, each electron, like each atom has their electrons, but those electrons are strongly bound to each other. They cannot move. So electrons cannot move from one to another places inside this material. So electrons are not moving, or they don't have freedom to move around the nucleus. They will be, see, electron, it will be sitting here itself. An electron here, it will be sitting here itself. So each electron, they will be sitting with their corresponding nucleus. Okay, but they will not be moving around the bulk of the material. Okay, through the material. So that means what? That so this insulator is not able to conduct electricity. Conduct electricity means it does not conduct electricity. It does not conduct electricity. That means what? There is no flow of charge, no mobile charge. So no mobile charge. So this is insulator. Okay, this is insulator. So there are examples, like if I give you, like say, like wood, you yourself can give some examples like wood, then plastic, ebonite, okay, silk. These are all examples of insulator. These are example of insulator. Okay, but what about conductor? Ion, then any metal will be conductor. Okay, obviously there will be some metals good conductors, some will be bad conductors. Like copper is the best. Like silver, gold and silver are the best. Then copper, aluminum, they are there. Okay, so any metal you take, they have mobile electrons to conduct currents or electricity. Okay, so this is how actually the materials are. Now I think we will stop it here for today. This was a very elementary, an introductory class. I don't know how you like it, and somewhat like in the beginning part, it is like when you read, you also may feel bored, but don't feel bored. You just read it. If you don't understand any part, you can tell me. But from this 1.4, section 1.4, the things will be more interesting. Okay, things will be more interesting from this part. Charging by induction, charging by conduction, and then we'll learn what is uh, quantization of charges and other things we'll be learning. Okay, and we'll be seeing many interesting example and like practical example. So this will help you to again understand and keep your interest intact with this subject. Okay, so the first part will be little bit boring. I would not say boring, but if you can understand, but still you may feel some boringness. But later on, from 1.4 sections, we will see this will be more interesting. Okay, okay, then we'll stop it here with this. So I think we'll have the next class on Sunday. You can give your feedback, okay, regarding regarding means how you are feeling. If I have to do anything else to make you understand whether more figures you need again, from some other sources, or anything else, you can just suggest in WhatsApp. You can just give your comments so that I can implement those things. Okay.